proof of the law of sines goes like this. I have a triangle ABC. These angles are not equal, or they can be. It doesn't really matter. But supposing they are. I'm going to divide this triangle into two. Down one of the angles to give me two right triangles. Like so. And I'll call this side H. Now I have angles A, B, and C, but since I'm dividing this B angle, I'm not going to worry about it. It's not necessarily divided in two. It's just divided to wherever will give me two right triangles. So I'm not going to worry about B for now. I'm just going to worry about A and C. Now what I'm going to do is take the sine of angle A and angle C. Sine of angle A is going to be H over C. This is the opposite, and this is a hypotenuse. And I'm going to take the sine of angle C, which is H over A. Now it's pretty easy to see where this is going. I'm going to set both of these equal to H. Rearrange this. I'll write it this way, so it's symmetrical. So I just multiplied the sides over to the other side. Now both of these are equal to H. Things that are equal to each other, I can set them equal to each other. So I'm going to drop the H. I'm going to say that C sine A is equal to A sine of C. And now I'm going to divide both sides by A and C. And it's going to cancel. I'm going to cancel out the C on this side when I divide by AC. It's going to leave an A. The A is going to cancel out on this side. It will leave a C. That's not very good C. So there I have sine of A over A is equal to sine C over C. So that's almost the entire law of sines. Except how do I get B from here? That would be the part that might confuse people a little bit, or they might not be able to see it right away. But it's a very straightforward process. And really all one has to do is just look at some minor detail. So here it's not readily apparent how from these two triangles I would get B, because I'm dividing B in half arbitrarily. I don't know what angle B is. All I know is that it's A plus 90 minus 180, whatever that angle is, but I don't know what A or C is. But what I'm going to do is take this same triangle and just cut it up a different way. So if this were the same triangle, A, B, and C. Last time I had cut it down the middle here through angle B. This time I'm going to do it through A. To do whatever angle will give me two 90-degree angles. Now someone might say, well, I'm dividing this arbitrarily to give me two 90-degree angles. How do I know that when I do the same thing that these two are going to be equal to each other? Well, the thing is that these two triangles are going to be the same proportionally. See, over here, I have a triangle over here, 90 plus C and whatever the missing angle is. Here I have the exact same triangle again. 90 and C and then minus 180, whatever that angle is. So this triangle is the same as this triangle because of the angles. And this is the triangle I'm going to be using. We're going to be bouncing off of this side right here. So when I do the same thing I did last time, it's the exact same triangle. So I don't need to worry about it being not equal, really. I guess when a lot of people do this proof, they don't really mention that in the book. And it's just sort of glossed over. I remember when I first did it years and years ago, I had that exact thing where I did not notice that right away, and I was just kind of following the process, and I didn't see why necessarily it should be like that. But it's really because this C angle is the same, this is 90, so this angle right here is going to be the exact same. So whatever this is right here, see, this is the same triangle, C, 90, whatever the angle is, because it has to be subtracted for 180. But anyways, now I just do the same thing again. Take the sine of C, revert to the other color. So the sine of C, in this case, I'll call this one H prime. How about that? So this line is not H, it's H prime. It could be a different length, but proportionally the triangles are going to be the same. And since the trigonomic functions are a ratio, even if the triangles are different sizes, as long as the angles are the same, the ratios will be the same. So that's the main point of it, really. So this is going to be H prime over, oh, I forgot to put the sides. This is B, C, and then A. So the hypotenuse here is B. And then this time I take sine of B, H prime over C. And it's the same thing as last time. Set them both equal to H prime. Set them equal to each other. And then divide out. And then I know from before that sine C is also equal to sine A. So let me just write it out one more time here more neatly. So therefore sine of A over A is equal to sine of B over B, which is equal to sine C over C.